These are the frequently asked questions for Algebra 2 for section 6.4 day 2. I'm going to start with number 43. Number 43, we can see that we have bases of 4 for both of those. And we certainly could do this problem using 4 to the 1/6 and 4 to the 1/3. But what we have to start realizing is that if there's a better base for a problem, you need to use that base. And 4, right away, we should be thinking, wait a minute, that's 2 squared. So we want to write that as the 6th root of 2 squared. On the bottom, we want the cubed root of 2 squared. And that's because we always want that smallest base possible. So take a look at what I have, and I realize I need to change these to fraction powers because the radicals are not the same. So the power goes on top, and the index goes on the bottom. And then 2/6 is the same thing as 1/3. And because we're dividing similar bases where the base is 2, we're going to subtract the exponents. So 1/3 minus 2/3 is a negative 1/3. You cannot leave negative exponents, so that'll be 1 over 2 to the 1/3, which is 1 over the cubed root of 2. Now we know we can't leave that, so we're going to have to go ahead and multiply by the cubed root of 2 squared, so it will have 3 2's. It'll be the cubed root of 2 to the 3rd, which will come out to be 2. But what you do to the bottom, you have to do to the top. So on the top, it's going to be the cubed root of 2 squared, which is the cubed root of 4. Now, again, you certainly could have just used 4 and gotten the bases that you needed for this one, but in this book, a lot of those problems will do that, but like in number 44, we're going to have to look at the bases again, and in number 45. So you should always keep in mind that if there's a better base, you should use that better base as you go through the problem. And by being a better base, I mean being a smaller number. So 44 just looks weird. It looks like, hey, there's nothing I can do here. We've got a 4th root and a square root, and even if we do change it to fraction powers, we don't have similar bases. So what we have to do is exactly what I was talking you through, which is start thinking about how could I separate this so all the bases would be the same. And I separated the 4th root of 18 into the 4th root of 9 times the 4th root of 2. And the reason I did that is because 9 is 3 squared, and that would of course be the best base for a 9, would be using the 3 squared. And then we have the 4th root of 2. And then the square root of 4, that's just going to be a 2. And now you can see the reason that I went after all of this in this way is because my bases are now 3's and 2's, and I can deal with those. So the first one, I'm going to go ahead and change this into a fraction power. That'll be 3 to the 2/4, which is 3 to the 1/2. This will be 2 to the 1/4 times 2 times 3 to the 1/2. And now we notice with that base of 3, when we multiply similar bases, we add the exponents, that's going to give us a 3. And if we multiply the 2's together, you can think of 2 to the 1st as 4/4. Well, that's going to be 2 to the 5/4. Now the problem came with radicals, so we're supposed to put it back in radicals. That'll give us 3 times the 4th root of 2 to the 5th. And if you're thinking, well, 4 goes into 5, you're absolutely right. So we're going to get 1 2 out in front, and we're going to have 1 remainder. Oh, and I wrote a y instead of a 2. 1 remainder underneath there. 4 goes into 5 once, but with an ugly remainder of 1. And so we end up with 3 times 2 is 6 4th roots of 2. So that one took a lot of work to get it down to where we needed it to be. But you always have to think about your bases. What bases can you use? So hopefully 46 is looking like something that's doable right now. You take a look at it and you go, oh yeah, 6. I can use 6 with the 36. So we really have 6 to the 1/2 up here, but let's spend some time rewriting that 36 as 6 squared, because that's what's going to make it so that we could actually do this problem with the same base. And remember that your index for your radical is your denominator, so that'll be 6 to the 2/3. Now, if we're going to do this subtraction, we need a common denominator. Least common denominator for 1/2 and 2/3 would be 6. So it'll be 6 to the 3/6 over, seems like way too many 6 in this problem, 4 6. So 3 6 minus 4 6 is 6 to the negative 1 6. Which means we have 1 over the 6th root of 6. Problem, we can't leave that radical down there. So we're going to need to multiply by the 6th root of 6 to the 5th. So down on the bottom we get the 6th root of 6 to the 6th, which is just 6. And up on the top here we have the 6th root of, and I noticed that your book is actually figuring out what these are at some point, so I'll go ahead and do the 6 to the 5th piece here. And that is 7,776 over 6. Just to show us, you know, eventually if you did want to use this for something, you'd want to know what that number is instead of leaving it the 6th root of 6 to the 5th. So, like I said, that one you didn't have to come up with, you know, some kind of weird base to do it all. You just had to notice the 6 squared. All right, we'll get this stuff up here, and we'll go to number 46. 46 has the square root of x to the 4th over y, and you need to remember that your index is your denominator. So it'll be x to the 4 halves, which is x squared, and then it'll be y to the 1 half. In your denominator, we have that lovely little 4 for an index, so these are going to be fourths. So if we have x squared, it's going to be x to the 2/4, which is x to the 1 half. And then our y will be 8 divided by 4, which is 2, or 8/4, however you want to look at it. So now we have a situation where we can go ahead and subtract because we have similar bases. So 2 is the same thing as 4 halves. 4 halves minus 1 half will give you x to the 3 halves. That is positive, so that's going to stay in my numerator. And then my y values here, again, 2 is 4 halves, so 1 half minus 4 halves would be a negative 3 halves. So I'm going to go ahead and put that y value down here on the bottom, just so that I don't have to have any negative exponents. But I realize that's a problem because I'm really having down there in the bottom, that's going to be the square root of y to the 3rd, and that is not simplified. So what I need to do is stop right now and say, all right, if I have 3 halves, what could I use to build this up to have it come out as something nice? Well, I just need 1 more half, because then that'll be y to the 4 halves, which is y squared. So whatever I do to the bottom, I have to do to the top, and I'm going to get here my y squared on the bottom, because I will have y to the 4 halves. And then on the top, we've got a lot of stuff going on, but I can see, hey, they're both square roots because they both have the 2 down here on the bottom. So I'm going to have the square root of x to the 3rd y. Now, one more thing I have to do. 2 does go into 3 once, but with an ugly remainder of 1. And that's going to stay underneath that radical symbol with the y that was up there. So that's a good problem. There's a lot to take care of in number 46, but in the end, you know, we've simplified as much as we possibly can. Then let me see if I had any down in this part. Yeah, it does not look like I had anything on here from 47 to 54. So next problem here will be 57, and it says write each expression in simplest form. So things to notice. Got a negative exponent there. So that negative means everything's going to be the reciprocal. So I'm going to go ahead and put that on the bottom. Now the 3 that's down there, that's not a problem, but that x to the 2/3 is. So what I'm going to need to do is multiply by a power that's going to complete that 2/3 and make it an integer, and that's going to be 1/3. So this will be x to the 1/3 in my numerator, and then I'll have the 3, x to the 3/3, which is x to the 1st. And then with this one came with fraction powers, so we would just leave that with fraction powers. Or we can go ahead and figure out what it is as 1 fraction power. And again, this is a problem where there are a couple of different ways to write this, your book did write this as the cubed root of x. That technically is not the correct way to do it because it came with fraction powers. But because the book said it's okay, I would have to take that as well. Remember, we try to stick with the form that we're given unless we're told otherwise, unless they would tell us, hey, put this in radical form when you're done. And let's see, then number 58 has a similar situation taking place. We have a 5, which is just a 5 over 1. And then we have x to the 2/3, but that piece is being raised to the negative 1 power. So that's going to be 1 over x to the 2/3. So now I have top times top, bottom times bottom, 5 over x to the 2/3. And just like in the last one, I can't leave that radical down there. So I'm going to have to finish that up with an x to the 1/3. And then on the bottom, I will have x to the 3/3, which is x to the 1st for number 58. And interesting, they wrote that one as a radical also. So they wrote that as 5 cubed roots of x over x. But the problem came with fraction exponents, so that is really the best way to leave your answer. Then the next one that we have here is 61, but I'm going to need some work here, some work room. All right, so number 61. There's a lot of different ways to deal with this one. What we want to do is pick the way that's going to make it the easiest. And the easiest way for number 61 would be to distribute the -6. So if we have half of -6, we'll have x to the -3. And then if we take the -2/3, and I just want to remind you of how to multiply fractions here. You can do a little cross reducing, and that would give you a +4. So then this ends up with the y to the 4th in the numerator and then x to the 3rd in the denominator because it had a negative exponent, so we needed to move it down. So again, it's all about how do you start, how do you make this easy. We certainly could have simplified in the parentheses first, but it just doesn't really make any difference in the long run, and I think it's a little easier just to go ahead and distribute that -6 for that one. Then number 62. Same type of thing. I'm going to go ahead and distribute that -12. So we have 2/3 times -12 over 1. And again, a little reducing, so that'll give you -8. So x to the -8th. And then your y, you want to take a -1/6 times the -12 over 1. Again, do a little reducing. We're going to end up with a -1 times a -2, which is +2. The y squared stays on the top, but the x to the 8th goes down to the denominator so that you have its reciprocal, and things work out very nicely there. And then again, I need some more room to look at 64 with you. All right, now 64 is different, and here's the reason why. When I think order of operations with 64, I'm supposed to do what's in the parentheses. There is something I can do in the parentheses here that's not just about negatives, because I can subtract those exponents because it's division. So 2 minus a -11 will actually be 13. So we'll have x to the 13 to the 1/3 power. Well, that's 13 over 1, top times top, bottom times bottom, x to the 13/3 for number 64. And see, that one they left. So yeah, I think they've just got a couple of different people working on this section that didn't speak to each other about how the answers were supposed to be written. 66. That one, you know what, I'm going to go ahead and flip these two because they both have negatives. It's not just one of them, it's both of them that have negatives. So y to the 1/3 over x to the 2/3, and all of that to the 15th power. Because there's division inside these parentheses, no addition, no subtraction, we can go ahead and distribute that 15, and 1/3 of 15 is 5, and 2/3 of 15 is 10. Y to the 5th over x to the 10th, and that one is done. Let's see. Next one I had here was number 67, which is a word problem. And that is the ratio R of radioactive carbon to non-radioactive carbon left in a sample of an organism that died T years ago can be approximated by the formula R equals A times 2.7 to the negative T over 8033. Here, A is the ratio of radioactive carbon to non-radioactive carbon in the living organism. What percent of A is left after 2,000 years? 4,000 years, got a 0, and 8,000 years. All right, and then it has a couple of bullets to help us out here, but at first you're thinking, well, something's missing here. You know, I don't have enough information because they're just giving me T. Well, that is what they're giving you. So R equals A times 2.7 to the negative 2,000 over 8,033. And what you're finding by doing the math for this in your calculator is a decimal that needs to be multiplied by A. That is the percent. Once you do that decimal, you have the percent. Now, again, your calculator is great for this as long as you use parentheses. So, I think I'll punch in the first one for you here and get you going on this. So we've got our calculator, and hopefully it'll turn on here and we'll be good to go. So we need 2.7. Okay, the calculator is refusing to work. So I am going to show you the keystrokes here. That would get you that. 2.7, caret symbol, negative 2,000 over 8,033. Give this one more try. Nope, it does not want to work. So, I'm going to go ahead and quit out of there. And you'll do the exact same procedures for the 4,000 and the 8,000. You're just going to be using a 4,000 instead of a 2,000. So for the 4,000 years, it will be 2.7 to the negative 4,000 divided by 8,033. And the last one over here will be 2.7 to the negative 8,000 divided by 8,033. And that'll give you your percentage. And for the first one, it comes out to 78%, approximately 78%. Wish you could have showed you that on the calculator, but since the upgrade, I've been lucky to get anything. This one is about 61%, and then this one is about 37%. So ask in class if you need to see those on the graphing calculator, because that smart calculator is just not going to work for me right now. 68 says the expression 0.036 m to the 3/4 is used in a study of fluids, which best represents the value of the expression for m equals 46 times 10 to the 4th. So we could just punch this in. But you have to be careful again that you put parentheses in before you do that 3/4 piece. Myself, I always punch this in the order of operations myself. You know, I'm going to punch in 46 times 10 to the 4th, enter. Then I'll raise that to the 3/4 power, enter. And then I'll take it times 0.036. Just so that there is no question that I am in control of what it's doing and not the calculator that's in control. And that's about 636. Scroll this up a bit and do a couple of these in the 70s with you. So number 74 is about numbers. And we have 100 to the 4.5, and obviously they're trying to hide something from us. Their 4.5 is 4.5, and that's going to be 9 halves. Well, what they were trying to hide was, that's the square root of 100 to the 9th power, and that's 10. 10 to the 9th power. So that's a 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros behind it. Right there. And then in 76, 76 is, again, what I was talking to you about earlier, which is, that the bases are so important. So if we can figure out a way to write 1,000 and 100 with the same base, then we can do this problem, which is good news because 1,000 is 10 to the 3rd, and 100 is 10 squared. And then when you raise a power to a power, you multiply. So we'll have 3 times 4/3. The 3's are going to cancel out, and we're going to get 10 to the 4th. And on the bottom, 2 over 1, the 2's are going to cancel out, and we'll get 10 to the 3rd, and 4 minus 3, 10 to the 1st, which is 10. So really about the bases there, getting those bases to match up. And on the next slide here, we've got another word problem. And this one is a desktop world globe has a volume of about 1,386 cubic inches. The radius of Earth is approximately equal to the radius of the globe raised to the 10th power. Find the radius of the Earth. So what we have to do is figure out the radius, given the little formula that we have first, and then we're going to have to raise that radius to the 10th power. So let's see here. We've got 1,386 equals 4/3 pi r cubed. So things to do first, we could go ahead and divide both sides by pi. Then we can multiply both sides by 3/4. So we'll have 3/4 times 1,386 over pi equals r cubed. And then once we get that answer, we can take the cubed root. So even though you can't see me punching this into the calculator, you'll be able to hear me. And again, I'm going to do the order of operations here. So 1,386 divided by, and the top of my pi didn't show there, pi. And then I'm going to take that times 3/4 and take the square root, cube root of that answer. And that gets me an R value of 6.916582163. But like it said, the radius of the Earth is approximately equal to the radius of the globe, there it is, raised to the 10th power. So now I have to take that little number and raise it to the 10th power. 250562113.2 is what my calculator spits out at me when I do that. So 250,562,113.2 for number 78. And the book really rounded like crazy there. This was in cubic inches. When we did our volume, oops, I'm going to take that off now. When we did our volume, we got it down to inches, and then we just increased that. Now, that's kind of goofy. So if you're going to tell somebody that many inches, you might want to divide it first by 12 to get it in feet, and then divide it by 5,280 feet that are in a mile. So it's really around 3,955 miles. All right, next ones on the list come from some in the 80s down here. Lots of good variables and numbers going on. So 84, when I look at this problem, I notice that I have like bases, and that's a good thing because that means all I have to do then is do a little subtraction. But I need a common denominator, so x to the 1/2 and x to the 3/4. Well, 1/2 is the same thing as 2/4. And then I look at the y's and I see 1s and 3rds and 1s and halves, so I want a common denominator there of 6. So that'll be y to the negative 2/6 and y to the 3/6, so that I can do my subtraction. So I have 2/4 minus 3/4 will give me x to the negative 1/4, and then negative 2/6 minus 3/6 will be a negative 5/6. Scroll this up a little bit, a little more room to work, because that means I need reciprocals. And this one, you notice, wait a minute, if I leave it like that, I am going to have the 4th root down there, I'm going to have the 6th root down there, and I can't have that stuff going on in the denominator. So I'm going to multiply by x to the 3/4, so that I'll have an x to the 1st in my denominator, and a y to the 1/6. But whatever I do to the bottom, I have to do to the top. So that will give me x to the 3/4, y to the 1/6, over x, y. And that, of course, tells me that I've rationalized the denominator and everything is good to go. And this one, just looking at the answer from the book, finally they got somebody that said, hey, we brought this to you in fraction powers, so it should give you an answer in fraction powers. Number 85. This one I'm going to do a little bit differently. I'm going to distribute that 1/2 right away, because 1/2 is square root. And I notice that I have some really nice numbers for square root. So 14 times 1/2 is 7. And then 81 to the 1/2, of course, that's a perfect square. And y to the 9th when we distribute that. So this will be 4x to the 7th over 9y to the 9th. And that one's done. So that worked out pretty doggone slick for number 85. Well, not that that wasn't enough. I think I'm going to stop there.